a 500-watt power supply, enough extra for studying and future growth. And then I think that is the last topic in this chapter, installing and maintaining the power supply. So since the power keep active, that is activate or active run all the devices, so we should take care of it, right? We should take care power supply. So installing, how to install, how to maintain. Okay, manage and maintain, install. We should know that. It's a part in the system. It's a section, right? Its job is to provide power, food. In our school, we have the canteen cafeteria, right? Canteen cafeteria. And in our school, you have the lab. In our school, you have the professor room, you have the many classroom, right? So our school, if we consider our school as a system, okay, then we can say that the power supply is the cafeteria. Okay, we go there and eat food and then we start work, right? So we have to know how to install that one and how to maintain that one in our system. Okay, installing process. While we are going to install, all the installing process is same. Okay, maintaining, what we should do, we should follow this thing, follow all of this thing, all of the installing, maintaining. If we want to install new processor in the mother in the system, we have to do the same thing. First, we have to disconnect with the outlet and switch off. Open the casing. Okay, open the motherboard and then remove the older one and replace the new one. And then again, uh, tight the screw and set the casing and then connect with the power supply, the outlet, and then start the computer like this. Never try to install anything with the outlet. When you are connected with the outlet, never. Okay, it's strictly prohibited. So we should not do any work connect with the outlet. Okay, for the maintaining and installing work. Installation, disconnect wires. Wires means that the cable we connect with the outlet. Disconnect it. All the cables we have the set wires, all the cables we have in the back, disconnect it. Remove 4 standard screw. We have in the power supply, you can see the 4 standard screw you can see. Or in the casing we can see 4 standard screw that is connected to the power supply. Okay, so remove this, remove PSU, and then the PSU stand for power supply unit. Power supply unit. Okay, PSU, power supply unit. To install, place PSU in case. To install, first is remove. Let's say problem in your computer in the power section. Then what do you have to do? We have to check the manual or visit the website, what power supply they suggest. Based on that, we put the order in the Amazon or Best Buy or eBay or Walmart. Okay, and then they give you they send you. We have many other also. They will send to you to your home. Then when it at your home, then remove it, or in your office. Then first, what do you have to do? We have to remove the older one, following this process, and then install the new one. First place, then replace screw, then connect wires. Interesting algorithm. This is called the algorithm working steps. We have to follow this algorithm. Look here, removing and installing, they're opposite, right? Removing means remove, install means add, right? Okay, one is the removing, another is the adding. So look here in the removing, first is disconnect is in the front. Here is the connect wires in the last. And then the remove four screw and replace screw. Okay, and then remove PSU. Then look here, place PSU. So during installation, first is the last work, and then second with the second one, and the third with the third one. Here the disconnect, here the connect. Okay, so you have to follow this. This is the power section. And this side some screw, one, two, three, four screw. Okay, we have some screw. Removing one, two, three, four. Okay, we have some screw here. Remove it. And then remove and replace the new one. So I think we all understand. Then the cooling. Oh, we need the cooling also. Cooling is another important part. Power section is related with the power. Energy is there. So it's very simple. It gets here hits up, right? This is consuming power. It's handling power. Some power may loss. Okay, hits up. So that is why we need the cooling system. Transformer is very hot. Sometimes if you touch backside of your computer or microwave oven, okay, or refrigerator, if you touch backside, then you can see feel hot, warm. Why? Here is some heat loss. Okay, so device heats up. So what do you have to do? If it is the limit, it can tolerate some heat. After that, it crash. Okay, then not to crash, what do you have to do? You have to use the cooling fan. Okay, cooling. Power supply fan provide basic cooling for the PC. Okay, so it's cooling since the power supply section inside the casing. So here's the heats up right inside. So if you use the one cooling fan here, then it drains hot air from inside to outside. Okay, it's like the air condition. Anyway, here's the fan means that the fan, okay, voltage regulator cool and provide a constant flow of cool air through the computer. Okay, here's the circulation. Cool air come, hot air out. A power supply fan stop, replace power supply. If fan not work, don't try to fix the fan. Just throw it and buy the new one. Okay, cooling fan may not run maybe for other reason that is related to the power section. So maybe cooling fan is good. We are not sure. So they suggest, and I'm suggesting you, if you see that the cooling fan is not working, just replace the power supply. Many fans have sensor to detect when they should run faster. Okay, here's some sensors. Sometimes O2 regulate. Okay, regulate. Sometimes we know that the temperature automatically regulate. Okay, uh, we if we have the sensor. Okay, sensor means that the it can sense that they have to run faster. It can sense I have to run slow. When you start our computer in the morning, then it's slow. But if you start working, it's also rotation increasing, and then it reaches its maximum rotation. Okay, so like this. So its case fan provides extra cooling for PC. Most modern computers have case fan, often plug into Molex connector. We know that Molex connector adapter can be used. Adapter can be used. Low cooling fan is the cooling fan. Wire fan sensor. Okay, here's a sensor connector. Keep case closed. Keep case closed. Sometime uh, this we should not keep like this. Close it. Here's a gaps. Look, gap. We should not keep this gap. We should close it. Okay, close. This window is for cooling fan. This window is for the cooling fan. Okay, or speaker. This for maybe for speaker. This for the cooling fan, and this we have the very other hole also that can we can use as air circulation. Okay, air circulation, and this is the this we have to keep close. Otherwise, what's happened? Uh, Roaches may get inside, or some insect may get inside. Dust particle can go inside, and we know that the uh, what is this called? Can you remember in the first chapter we understand electrostatic, static. Okay, so there is some dust particle here, electrostatic discharge, something form here, some charge here, right? And then if we have the dust particle, then we have the moving part, moving fans. Okay, then as a result, if too much dust particle here, then they hits up. Okay, hits up. That is why we should keep close, right? So if you keep the all the time window open, then dust particle, too much dust particle come in our house, right? And we are not feeling good, uncomfortable. Similarly, devices inside are not feeling good, then they crash, damage. Some fan can be adjusted. Okay, we can adjust. Okay, manually adjustable with the knob, software adjustable by sensing heat. Software also we have. Through the software, we can also adjust by software written by the some programming languages. We have to use the conditional code. If else statement we have to use, right? Statement we have to use, or the some uh, control software we have to use. This through this you can control it. Okay, if the temperature is 10 degrees, then rotate like this. If the temperature is 20 degrees, then rotate like this. If the temperature is 30 degrees, then much faster, and then 40 degrees is very fast, and then the 50 degrees, 70 degrees, 100 degrees, then extreme high speed, like this. Okay, larger fan that spin more slowly are quicker. Higher end fans are quicker. Okay, use better bearings. Okay, use better bearings. Bearing, you know that the bearing is a wheel, something, okay, that can run smooth. They help to run smooth. Okay, smoothly run. It's circular. Okay, this is support, and here is the bearing. Some ball. Okay, spherical ball, metal ball. Okay, and then it's rotated, very fast rotate. This is rotate. It is rigid. This part is rigid. It is rotating. Okay, interesting. There is the mechanical part. So fan speed we can check, because I told you that we can control by the software also. So in software we can check it here. So we are done. I think how many slides left? Power supply fail in two ways: sudden death, slow over time. Okay, slow over time. Sometime suddenly crash because it's power. Any circuit or anything happen, then disconnect, break. Okay, in that case, computer simply stop working. But when the slow, then computer we can work, but it's also no good. When you understand, then replace it. So output voltage may exit here. It is plus minus 10. Okay, maybe I told you that the voltage we have a plus minus 10%. 10% maybe the said it is 12 volt. 12 volt. So plus minus 10% means that it's maybe uh, plus minus 10% of 12 is 10 by 100 into 12. Okay, then if we cut it, and then if we cut 12, then it is 1.2. So plus minus 12, what does it mean? Its meaning is that the 1.2, sometime plus with the 12 volt, sometime 1.2, okay, we less, okay, 12 minus 1.2, that is 8.8 volt. Okay, 8.8 volt is okay, and 13.2 volt is also okay. They say plus minus is okay. If it is more than that or something below that, then it's a problem. Then slow over time and then the damage. Tolerance, it is called the tolerance. Tolerance range, what he found? Tolerance range is here. The minimum is 8.8 and maximum, it is called the range. We can define by this sign. It is 13.2. Okay, 8.8 and 13.2. In this range, it's okay, our device can work. Anyway, so this is how to calculate this thing. Power supply test. We can test the power supply by using the multimeter. The same multimeter, okay? That we understand. Set the multimeter to DC. Test it. And then if the rate is called the live and it is the neutral, now they're testing, you have to test. Here the voltage is 4.6 volts, 4.7 volts. It's okay. It should be about 5 volts, but it gives us the 4.7 volts. Giving us the 4.7 volts. The 4.7 volts, if you do the plus minus of this, look here, plus minus of this, you understand plus minus, we did one calculation before. Then it gives us the plus minus of this, give us the 0.5. So 0.5 will minus from 5, then 4.5, and this again it will plus the 5.5. Look here, here is the reading is 4.69. So it's in the range. Interesting, right? Similarly, for other all voltages, you can calculate the same way. Look here, the way I calculate here, same way. First, you have to find the plus minus 10. From where? I show you example based on the 12 voltage. Okay, 10 divided by 100 into 12. That we understand in our junior high school or something like this, right? You know that all. You all are expert. Since this came here, that's why I'm telling you. I'm working again with you. So 10% of 12 volt, 10% of 12 volt is meaning is 10 divided by 100 into 12. So it gave us the 1.2 volt. 1.2 volt, then plus minus. We have to plus minus. Okay, plus minus. If we do plus minus, this is the that we found here as a voltage, 1.2 voltage. That voltage we have to plus minus. First time add with this, and first time subtract this. Okay, so we found the range 8.8 to 13.2. Okay, polarity is okay if you don't mention your polarity, that is the negative sign or plus sign, it's okay. So we can write like this, that is the range. Okay, magnitude we can consider 8.82, 13.2 voltage. Similarly, they show some calculation here. 5%, 10% of this, 10% plus minus 10, meaning is that the 10%, if we do, the 5 voltage is 10% is zero point 0.5. So zero point 0.5 will subtract from this 5 is 4.5, and zero point 0.5 will add with this 5.5. So our reading is in between. Okay, it is perfect. Understand how you will understand the power supply is okay or not? This way. If you see the reading is 3 volts, actually it should be in this range. But if you see here 3 volts, no, we should replace it. If we see here the 7 volts, no, we should replace it because highest we can go 5.5, not 7. Interesting. Similarly here too. Okay, we have the this is maybe for the CMOS battery, is maybe for your ROM or cache. Okay, ROM is very low voltage maybe we need. So then we have to understand what is the tolerance it can tolerate, something like this. Okay, so these are the thing, interesting thing. We understand many very interesting thing. Now let's keep up to this. Uh, okay, done. This is the last slide. Okay, power supply. Through power supply, that glow blue. We have this type of power supply. Sometimes you can see this some computer blue glowing different color. So it's like this. Okay, interesting. So anyway, our this chapter is done. Do you like a gentle break? Do you need a gentle break, or I can start the next topic? I think it's better to take a gentle break. Okay. Okay. Oh, you can start. Okay, then let's start. It's better. We can complete early, we can leave, right? Good. It's wonderful. So here the power supply gone, and then the hard drive technologies. The file is loading. Just 1 second. I'm bringing my water cup, water glass. Just 1 minute. Okay, we are here with the new topic. That is the hard drive. Hard drive. Uh, hard drive means hard disk. Okay, hard disk. Hard disk mechanism we are going to understand. Uh, Memory, storage, processor, power supply, motherboard. These are the important, right? Important, and then the connectors, and then the uh, networking system, right? So that is why we have to focus more on this chapter. Hard drive technology. Okay, another interesting chapter. Hard disk, how it's look like. We just heard the name, right? Most of you heard the name hard disk, but what going on inside of this? Inside is like this: manipulators, manipulate, and then here is our data. Your video game, your programming, your movie, your file folder, my lecture, the lecture you saved in your computer, this lecture, all in this plate surface. And that is called the arm, and it's the head. Here is the top of the arm. We have a head, okay? That is called the read write head. Read write head, this head is not only in one side, it's not only in one side, both sides. So this is the plate. For this plate, it has the two head. One is in the top and another in the down. Another set of the heads in the top, another sets of head in the down, both side. So hard disk use both face of the plate. CD-ROM. Did you see the CD-ROM? DVD. Did you see the CD-ROM? CD. Christopher, Reto, Collins, CD-ROM. Have you heard the name CD disc, compact disc? Okay, great. So CD, we can use only one side. CD only one side. In the car, okay, in the car we use the CD. If your car model is before 20, before 15, then we mostly use the CD, right? Now the both we can use, but the time is mostly CD, especially around 2000, all CD, right? The CD we can use only one side, one face we can use, not both the faces. But in the hard disk, both faces we can use. In the hard disk, not only one plate, many plate, one, two, three, four, five, and maybe more. Our data, all of the data are in these plates. Okay. So how is work, how to maintain it? We should know that. Okay, hard disk is the very important storage. Terabyte hard disk, gigabyte hard disk. Very important storage. So that also we should know how to maintain it, right? How it's work, we should know that about this chapter. Okay, hard disk technology. This is all theoretical. The thing I said in brief, and throughout the chapter you'll understand this thing. So this we are going to understand. How hard drives work. Hard disk and hard drive, two different things. Hard disk and hard drive and hard disk, two different things. Disk is disk, while data store, and drive means disk run by drive. Okay, driver. Driver. Engine is engine in the car. Car is car. Engine is engine. Okay, we people sit in the car. Okay, and that car, the bus run by a driver. So disk where we people sit in the bus. Okay, that bus is called the disk, and the disk is run by a driver. A person is the driver. So hard disk run by drive. Keep in mind. That is why the name is DD, hard disk drive. And hard disk is only SD. Hard disk, only SD. Okay? And hard disk drive, that is the driver. Oh, clear? The platers are made up of aluminum. Platers means that the platers you found here, hard drive. So where you found the platers, this plater, made up of aluminums and then the magnet. Interesting. Just you have to read. Platers are made up of aluminum and coated with a magnetic medium. Two tiny read-write head, we can see there, service switch plater. Two tiny read-write head, service switch plater. I told you about the read-write heads, and these are called the head. This top is the head, and this head is read-write. Read means when you open file, it is called read. Okay, let's say you have an exam tomorrow, then you try to open some file. When you open file, then it is called read. When you save file, you type some data and saved. Okay, use the save button, save, then data save. Okay, it is called the write. When you save data, that means we are writing data. And when we are opening data, opening file, that means we are reading file. That is why the name a read write head. Okay, read write head. This way read write head came. So this is the summary of this chapter. Just you have to read this thing. Very simple. And then this is the hard disk, we all know. Inside, if you remove this cover, then you can see something like this. And this rotation, when hard disks run, is run very high speed. Very, very high speed. About 15,000 revolution per minute. It's very fast, okay? That is why we can, when you start computer, then you can hear some spinning sound. That is hard disk is running. Okay? We can see, we can hear another sound also. There is the cooling fan for the cooling fan movement also. You can hear the sound, but the hard disk sound is not like the cooling fan sound. I told you that the 3,500 revolution to 15,000 revolution per minute. Plater speed. Oh my God, it's very, very fast. And then the hard disk closer, data is very high dense data. If the plater close, the area close to the head, the area close to the read write head, there the data density is very high. Densely data. Okay. If the hard disk is far from, then the read write head is far from, then there is the less dense data. That is the saying, closer the read write heads are to the platers, the more densely the data can be packed onto the drive. Hard drive is a tiny, heavily filtered aperture to equalize the air pressure between the exterior and interior of the hard drive. Interior exterior air pressure equalize. Okay, tiny, heavily filtered aperture used in the hard disk that equalize the air pressure. Air pressure is important. Okay, good. And plater spin between 3,500 to 15,000 revolution per minute. Okay, great. This is the head. It is the arm, actuator arm, and that is the head is in the top. I said hard disk both side, both face use. Look here. I have a class for the graduate, okay? In the graduate class, I teach them in practical. Practical means that they can see open and then they can take, because nowadays you have the many software, okay? And that is the graduate class, right? Graduate class, you know, that when you're a graduate student, then you have to learn everything in detail. In our class also, you have to read everything in detail. That is why you'll see that I never skip this slide. Okay, I skip, but not the like the from one chapter I'm teaching only 10 slide, not like this. I'm also trying to give you the maximum thing so that you can use. You can practice, you can learn, and then you can use it for your future. So this is the head. Both side we have the two. Here is also one, bottom was one. Okay, top side and bottom side both. Data encoding. Okay, data encoding. So hard drive store data in tiny magnetic field. I told you that the magnetic field is there and this data stored over there. And this field is called this magnetic fields are called fluxes. Okay, fluxes. We have a in the electrical engineering class, in my class, there we understand about the fluxes. Okay, same thing here. And magnetic fluxes means that this magnet is converted to magnet. Magnet means, do you know what is magnet? Magnet is a metal that can attract and repel. That can attract. Magnet can attract or repel, oppose. Attract means if you bring iron, if we place iron near to the magnet, then it's attracted by the magnet. Or if you put the magnet beside another magnet, okay, one magnet, if you bring another magnet, then they're also attract, also repel. What is the attack? Attract. Attract meaning is that they on the opposite pole. Let's say we have the two magnets. We have one magnet here, another magnet here. Let's say it is north, it is south. Magnet is the two pole, north pole and south pole. Have you heard this polar region on the earth? Polar region? Pole. We also have the north pole, south pole. Earth is a magnet. Do you know that? Do you know Earth is a magnet? Who don't know? Who are here that we don't know that the Earth is a magnet? Earth is a magnet. That is why if we try to jump, we come back. We try to jump and go space, but we cannot. We come back. Earth attract. This substance can attract and repel. These are called the magnet. Then you may have a question, hey, Dr. Kazi, then the earth only attract. Then how is the repel? So earth repel other planet. That is why planets always running in their own path. Okay, one is repelled by the other. Okay, and other way they attract by the other. But attraction repulsion is cancel out, zero. Zero means you are in your position, I am in my position. So you're driving, I'm driving, no problem. Right? Like this. So Earth also rotating, Mars also rotating, Venus also rotating. Okay? Neptune, Pluto, and then the Uranus, Saturn, all are rotating, right? So even Sun also rotating. So from their own position, own axis. Attraction, repulsion cancel each other and then they are moving in their own path. If only attraction, then everything tightly packed. Everything tightly packed. Okay, we all together, one after another. Okay, or if it's only repel, then always we are going far back, back, and we are distance from you to me, and all are increase. Okay, that is why they say it here. North Pole, South Pole. North Pole, South Pole. Pole meaning is that before magnet they are just like this metal. No NS. NS came out. Spinning is that the MS is here. Spinning is that it's a magnet. Did you see magnet? Who is here that did not see the magnet? Cedron. Did you see the magnet? Christopher, did you see? Clayboy, Collins, Isabella, did you see magnet? Zadan said, yes. Yes, yes, you all see the magnet. We play with the magnet. When a kid, when we are small, then we used to play with the magnet. Okay, I have the magnet. I can show you just 1 second. It's a very strong magnet. Okay, let's see this one. What do I have any metal here? Okay. Okay. The form on metal. So okay, look here. I'm sharing the video. I think you can see this is the magnet. It's a very strong magnet. Okay, and is this is the magnetic metal? Iron. Okay, iron or steel. Look here. Okay, so similarly, there's the plate we have in the hard disk. This plate convert to magnetic, and then form the North Pole, South Pole. And when they polarize North Pole, South Pole, and come in a line, then it's ready to store data, our data. Okay, interesting. So that magnetic, by using the magnetic force, we can do many things. Do you know maglev 10? Anyone here know about the maglev 10? It's very interesting technology. Japan made one train. It's run about 600 kilometer per hour. Can you imagine 600-kilometer train move? That is the maglev 10 magnetic train. Okay. Magnetic train move 600 kilometer in 1 hour. It's not a matter of joke. So magnetic force, if we can use properly, then we can do many, 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 many things. Clear? So by using the magnetism, our hard disk, sometimes we are saying magnet disk, magnetic disk and hard disk. Okay, magnetic disk, same thing. So by we are using the magnetic concept, and then we are storing data over there. We use the electromagnet there. We are using the iron filings. Iron filings means the iron particle, small particle. And this particle, if you pass through the electromagnet, then it's converted to come in polarized like this, and then it's ready to store data. We can put data over there. Data means that the our 0 1 0 1 0. You know the binary 0 1 0 1. Can you see all of this here? It's very interesting. Please, when you have the time, try to read, understand. So magnetic force, if we can use the magnetic force, if you can use the uh, electromagnet, we have a course electromagnet, electromagnetism or electromagnet. Its meaning is that the electricity and magnetic field together. Okay, and then when we keep the electric field and magnetic field together, then it's their combined effect release one ray. That ray is called the electromagnetic spectrum, electromagnetic wave. That's very interesting. Anyway, so by using this, we can store data. Just to read here, fluxes in one direction are read as 0, and then the other direction are read as 1. Look here, N and together is 1. 0 S's together. S means south pole, N means north pole. When the opposite pole, they attract. And when the same pull, they repel, push back. It's interesting. And then encoding method used by the hard driver, two method we have here, run length limited, and then the partial response maximum likelihood. Okay. One is the run length limited, can have runs of about 7 fluxes. 7 fluxes can run. And then partial response maximum likelihood, it can run about 16 to 20 fluxes. Okay. Magnetic field lines, flux. What is the flux mean? Okay, where is my pen? My pen is here. So field lines, look here. Field lines runs from north to south. Keep in mind, always lines runs from north to south. Okay, these are called the flask. Okay, flask. So here is the run length limited. It is the can have run about 7 fluxes, and then partial response maximum likelihood can have runs of about uh, 10 to 20 fluxes. Okay, there are many lines in the flask. Okay, many lines in the many is an uncountable line. Not only I mentioned here, I marked it, this is the field. Okay, flux line, these are called the flux line, but not only three, many lines. Arm movement, what does arm movement mean? You know that I told you in the slide we found, what we found? Where is the slide? Oh, here, let's go to the here. So arm movement, here's the arm. Okay, this arm move. What is the better slide? Let's go to the, okay, we can use this one. This is the arm movement. Okay, when we are not using the computer, we are not saving data, we are not opening data, okay, opening or closing data, then arm is head is like in the rest position. It is called the landing zone. Okay, landing zone or L zone or LZ. Okay, L zone or LZ. LZ, landing zone. But our data, our data, eh, we have the many programs, many things in our computer. Where is which one? Okay, hard disk can find quickly. This head can find very quickly. So it has to move based on this arm, rigid arm, right? Our hand, look, our hand, we are shaking, jumping, right? It's rigid here, right? We can move here and there. Here is my this, here is my that. We can grab and we can use. Similarly, here is the hard disk. Is your C program is here. Then hand go there. Here is your Java program there. It moves there, and here is your video file. Here is your game. So similarly, small and bring the data. That is where we need the actuator and then the arm. Faster movement. Okay. Aeroplane and then the drone and then the many things. Everywhere we are using this one. Clear? This is the mechanical part of the electrical. So the head actuator that helps the movement, faster movement. Okay, move the arm in a fixed increment or step, only seen in the floppies today. Okay, today we are not using floppies. Okay, floppies we can see that one. Also, we have the many uh, places we have to use the head actuator that helps to move the head faster. Here also you are using this one. And then the bias coil technology is a permanent magnet. Permanent magnet. This is called the permanent magnet. The magnet I show you here, it is permanent magnet. Look here, it's permanent magnet. One magnet we have that is called the temporary magnet. Can you give one example of the temporary magnet? It is permanent. The magnet I'm showing you is permanent. Can you give one example of the temporary magnet? You all know. Or doorbell. Okay, doorbell, when you press the bell, cring, cring, right? That is the temporary. The time we press, okay, we push, okay, we hold it, the time is ringing. Remove hand, then stop. That is why it's called temporary magnet. When you push, then it's magnetizing and then this giving us sound, working. When you remove, demagnetize, there is no sound. Interesting. Geometry. Okay, geometry. That is how it's work, how the device, how the magnetic plate look like. Okay, uh, we have the sum. Uh, what is this called? Based on the sum uh, rules and parameter, hard disk work. Okay, that we can define in the geometry. That is the cylinder CHS, cylinder head sectors. Cylinder is cylindrical. Okay, mounted in the center. Look here, many plates. Look, this part is cylinder, right? Cylindrical. It's like the cylinder. How the cylinder look like? Can you remember in our high school we learned the find the area of the cylinder, volume of the cylinder? Cylinder is something like this, right? It's cylindrical. Look, it's cylindrical. And then cylindrical. Okay, cylindrical. Anyway, so and then the side We learn many things. Cylinder heads, and then the sectors. Okay, sector. What is the sector? One is called track, one is called sector. The sector, where to write? Okay, I'm showing you the sector. Where is the sector? This is the cylinder. Okay, look like the cylindrical, right? Cylindrical shape. Okay, many plates here. And track, this is called the track. Track, circular path. Circular path is called the track. And then you divide the circular path in some small sector. Okay, these are called the sectors. Let's see the sector in the next slide. Look, these are the sectors, sector. And here's the thousand tracks. Track, in the high school sports or our campus sports, you have to run in the track or in the stadium, okay, or a gym. We have some line, circular line to run so that we cannot collide with the other, okay, sportsman or athlete. Similar thing here. Okay, we have the many circular lines, and first you divide circular line, first you create this plate and then divide circular lines and then divide into sectors. This sector, one type of data, another data, another data, another data. We have the many portion here also, cluster also. We have the data in different location. It's well organized, you know, well organized. And who is the responsible for this? Operating system. Okay, operating system. Operating system format the disk. Disk formatting means it is ready to use. Okay, disk formatting meaning is that the track sector, these are created. And then we can use it. Interesting? Good. So about this, they said in the previous slide, just you read this thing. Yet they said, keep in one mind, I told you that how many platers here? 1, 2, 3, 4 platers. How many heads supposed to be? Each plate has 2 head. Keep in mind, you'll get question, this type of question. Each plate has 2 head. If 4 plates, then the 8 heads. But some head we use for system use for itself, special purpose. Okay, that is why we cannot say always that the number of head is always double. Here's the 4 plates, 8 head. It is true, 4 platers is 8 heads, but in the system, oh, my battery is running low. 1 second. Okay, great. So extra head sometime, okay, that is why we cannot say always. But if I give you some question that let's say 4 platers, how many platers minimum here? Then you have to say double, 8. Okay. So we have the other heads for the hard disk, other purposes, but in general we can say here is double. They said most hard drives have an extra head or 2 for their own uses, so the number may not be even. Head number always even. We know, in general we know. Why? Because 1 double is 2. If the plate is 3, then 3 double is 6. 6 is even number. If the plate is 7, then 7 double is 14. 14 is even number, right? That is why they said about the even number, but it is not always true. Why? Because sometimes we can see the extra head for the hard disk itself. Okay, hard disk itself. In the restaurant, when they sell the burger, They count, finally they count what they count. They count that they how many they sell outside. But in the all day long they eat few burgers, they didn't count that. Let's say five burger they eat it, and they sold 20 burger. Actually, how many altogether? 25, right? Like this. So for their special purpose, some hard disk, extra head they need, okay, for the other reason. And so the worker work in the burger shop, they eat, they also have to feel hungry, they need for their purpose, some like this. So extra hard head we can see, that is we can say never, that is it is always even number. Cylinder, we understand about the cylinder, cylindrical things, okay. And then the track, I already explained about the track, circular path. And then sector, you understand, I told you that the divide, this is a sector, is one sector. It's another sector. It's another sector. Let's say Isabella sector. This is the Southern sector, okay, and Zayden sector, and Zoana sectors, and then this, okay, different sector, okay, different sector means that here's some different one type of data, another type of data, another type of data, okay, and this all done by the we have logically, everything logically. Uh, why logically? Well organized data are well organized here. Otherwise, hard disk cannot find it so quickly. The data we look for, we just click, it's open. How? Because data well organized, and hard disk run very fast. Had runs, had moved very fast by the arm, okay, actuator. Clear? That is why we can get data quickly. And data are always well organized. And it is done by operating system. Okay, during format, hard disk format means it's ready to use. Okay, we understand many things. Okay, right precompensation cylinder, and the specific cylinder from where the drive would start writing data for their part, and then internal sectors physically smaller. Internal sector, of course, internal sector. Look, internal sector is smaller. The sector is small. We know that. Okay, and the external sector is very big, right? It's occupy more space, more space. It's simple. External sector physically larger. We know that. This identified cylinder where spacing changed, and then the landing zone is okay. After work, head come in its own position. That is called the landing zone. Like the helicopter, it flies and then comes and take rest. Okay, landing zone. Where no order, no passenger, no visitor, then they always on the deck. That is the landing zone. Hard disk also head also it has the landing zone, and no work, no request, no nothing, then it take rest over there. Like the way we park car at our home garage, parking lot, right? Like this. Good. So these are the thing. Here the speed, already told you different speed we have. 15,000 you can see as the highest, maybe much more. For the supercomputer, much higher speed, you know that. So usually this is also too high, 15,000 revolution per minute, RPM. 15,000, can you imagine? It's very high speed. Okay, good. Now, what is the problem? Faster rotational speed produce heat. Faster movement, more heat. If you run slow, it's okay. But if you run very fast, how you can be fast? Let's say you five friends together start to run. Who can be fast? Okay. So we are looking for the first. Who can be first? Then, oh, uh, what do you have to do? You have to run very fast. Okay, to be fast, to be first, you have to run very fast. And when you run very fast, then you're sweating, you're tired, right? Heat produce. Similarly, faster rotational speed produces more heat. Clear? And then airflow is important. Then we have the cooling fan, right? We have to use the cooling fan so that we can balance it, minimize it, reduce heat with the case fans or bay fans. Before like this, I show you some. I told you that there's like the window in the back side of the my desktop. I show you like the window. It's like this. Okay, circulate. In the side also you can see something like this. Okay, circulate air. Circulate air means circulating air means hot air come out, cold air in. Okay, hot air out, cold air in. And then the solid state drive. Solid state drive. Nowadays we are using the solid state disk, right? SD card. We are saying the SD card. SSD, that is solid state drive. Solid state drive is advantages. Do you know what's the advantage? It is no moving part. No moving part. Since no moving part, so it can respond quickly. Understand? Moving parts means that in the hard disk, it is to search where it is. Search with the head and grab it and give open it, right? Or save something like this. But in the SSD, we don't need the moving parts. If no moving parts, then we can obviously we can reduce, we can minimize time. Less time means faster, fast. Okay, since the moving parts is fast, but is it has a disadvantage. What is that? Expensive. Okay, expensive. DRAM and flash-based drive later are more common. Okay, DRAM is another one. Okay, solid state technology in the hard drive, memory card, and more. Okay, we can see many ways. We can see the solid state technology as hard drive. Okay, as a storage, as also memory card, and also for many more. Right, we are using this one also. We have the flash drive. We have the scan disk, rectangular shape, right? And then we have the pen drive. We have these are also the same solid state drive. Advantages, I already told you that the solid state no moving parts means is consume low power. No moving parts is consume low power, less power. You know the Tesla car, Tesla engine. You know the Tesla mechanism, engine mechanism is much less than that of the ordinary car. Okay, normal the car we have in the road like the Ford, the Toyota or the whatever it is. So that is why Tesla is environment friendly. There is no more minimum moving person there, and then we can save more energy. Low power consumption. No moving parts. There's low power consumption. Very fast. Since no, it does not. It don't need to search. Immediately it can respond. Okay. That is why faster. Okay. Since no moving parts is mentioned here. Extremely rugged. There is nothing to break. Since no moving parts, hard disk is the moving part. So it is here's a chance to break. Arm may break. Okay. Or plate may break or something may happen because it's moving. In case of the SD extremely rugged, nothing to break. Here is nothing to break. No moving part, nothing to break. Disadvantages. Disadvantage is with the, how to say, disadvantages. It's related with the money. Okay, so here the disadvantage is based on the money. Hard disk per gigabyte is about 10 cent. Per disk, hard disk is 10 cent. It's very cheap. 1 GB. 1 GB is use capacity. Whereas one 1 GB SSD is $3.5. It's about 35 times more expensive than the hard disk. So it is the disadvantage. Another disadvantage, SD capacity also much lower than the hard disk. Hard disk is very high capacity, super high capacity we can go. But we can go also SD card, but we have to pay a lot of money. Lot of money. Use money you have to spend. So we can save money, time, and energy by using the SSD, okay, than the hard disk. Okay, I may ask you about this. You have to write this thing. What is this? That the we can, it's economic, environment friendly, so no chance to break. Okay, faster movement, low power consumption, save money. Many advantages you can write, right? So ATA interfaces dominate today market. ATA, advanced technology attachment, we know that. Many changes throughout the year. Parallel, parallel ATA, that is PATA, PATA. Serial ATA, serial advancement, advanced technology attachment. So it is SATA and called integrated drive electronics, IDE. Okay, called integrated drive, uh, IDE, integrated drive electronics. Okay, my student, I'm not going further. Let's keep up to this. Read up to this for your exam. I'll check what I can give you for a specific topic from here. Then I'll add in the next class. And then the next class, mm, I'm going to assign one work. Yeah, I'll check if it is possible to set for one sit for one quiz. I'll let you know. Otherwise, I'll give you one assignment. Okay, I already conduct three quizzes, so one assignment is okay. Otherwise, I'll give you another quiz that you have to submit.
Also, Professor,
And
Professor,
yes, please.
what is going to be the next quiz, next class?
Next class is next week. Is the last class before the final.
Oh, so next class is the final then.
No, no, final is on 20th. I already said final is on
On the
20. Okay.
20th? 20, okay.
Yes. 13 13th of this month we have another class. In that class we are going to discuss about the final exam, okay, detail. And then we are going to discuss about the two topic. One is the wireless network, uh, and another is the uh, security, cyber security. Okay, security issue. Also, you have to keep concern about the security, right? About these two topic only you are going to understand. And then I'll think that the if I place, then I'll say I'll tell you to sit for one fourth quiz, or not. Then I'll assign one assignment that you have to submit by 1 week. You'll get, if quiz, then you have to sit for a complete in 1 hour or 40 minutes. But if I assign the assignment, then maybe you'll get 5 days time. Okay. Everything is easy, smooth. Please read all the lecture notes that I posted in the Canva in the class Blackboard, and I'm going to post today in lecture note also. And so please try your best so that we can you can do better in the final exam, and I also can uh, your better exam will help me to give you better grade, right? You senior, you know that, right? You have to study more study, more practice.
Also,
If you do not
Professor,
understand, ask me.
can you
Yeah.
put up Blackboard the like the date and stuff so to remind us what is the quiz and the final and stuff like that?
Yeah, I'll post everything in the Blackboard.
Oh, okay, okay.
About the final, I'll post everything. About the quiz, if any quiz, I'll post it. Of course, I'll post it. Okay,
No, I was
good.
talking about
Now,
the date, like the
take
date,
your attendance.
minus
Yeah,
of the
sorry.
date.
Yeah, I'll post. I'll try to post tonight or tomorrow. I'll do it soon. Oh no, we have
Okay,
1 week time. Don't worry. Final exam, we have 1 week to one more class. So I'll post it before the next class so that we can discuss if any issue. Right?
okay, okay.
Wonderful. So please give me 1 minute time to take your attendance, and then I'll ask you individually if you have any question, so that we can discuss. And Court Livia, if you like, you can enjoy your day. We are good. Thank you.
Okay.
Now I'm going to take your attendance, please. First is Cedron. Okay. Professor, I did not get to submit lab 4. Maybe date is expire. Okay, I'll open it for you. Uh, would you please send me one gentle email so that I can keep in mind? Uh, I'll keep open. Okay, good. Okay. Now I'm going to tell you name, please, one by one. Just response, and then you can leave. Hey, one student leave. Why? I didn't take that in this. Cedron is here, right? Cedron. Christopher. Okay, wonderful. Bernice. Boy, Bernice. Okay, great. And then Collins. Collins is here. Okay, good. And then the Garcia. Okay, can you reopen the lab? Yes, I'll reopen. Send me one gentle email, okay? Garcia is here? No. And then the Isabella Roses. Great. And then Zaden? Wonderful. And then the Zaiden? Zaiden? Zaiden. Okay, great. Volkov? Oh, Volkov is absent today. Why? He's regular, very regular. I don't know why he's absent. Okay. Zoana? Zoana. Great. Oh, I didn't ask you. Do you have any question? Please let me know. Minda. Minda, do you have any question? Are you not here today? Why? And then the Roito is here. I'm sure he's here. He's very regular too. Good. Do you have any question, please? Okay, great. Enjoy your day. Baldono. Baldono.
Yes, Professor. Did you get my lab? I sent it over. Did you receive it?
Which lab, please? I'm sorry, I'm
I
here.
think he's
Okay,
on the
let
lab.
me.
Lab 3, right? You post lab. That was the only lab you post, correct?
No, I posted whole lab, and we discussed. I discussed two more lab with the class, and today also we discussed one lab, right? How to measure the current, how to measure the voltage, right? This lab, two labs together we discussed today.
No, no,
We are
no.
doing all.
I'm talking about the lab that you post for lab 3. I only see once I'm on Blackboard now. I only see lab 3.
You cannot see lab 3, right?
No, I did. I did. That's what I'm saying. I'm asking if you received my lab 3.
Okay, once you name place, then I have to check. Lab,
Yeah.
don't, lab just lab. You just have to sincerely do the lab. Okay, but lab is not in our grading. Our we have to focus more on you. Yes, lab 3 is it did not submit it? Oh, if you do not submit, then I have to reopen for you. Okay, then you have to send me one gentle email. Okay, give me a
Could you, could,
reminder.
could you check it?
Okay, then I'll give you. Today is the Monday, right? I'll try to open tonight. Or okay, I'm doing it now. Okay,
Professor, could you check if I submit
and
mine? That's all I was asking.
you will get only 2 days for the resubmit. You'll get 2 days. Okay, okay. I think it's enough for you.
Professor, can you
Three.
check if I submit mine?
Sorry.
Can you check if I submit my lab 3, please?
Yeah, I'm checking on that. You see it. Okay, okay. What's your name, please?
It's daily.
Uh, your name is
Foldado.
okay, Baldano. Baldano. I just 1 minute.
Okay.
Mhm. Bulk up. You bulk up. Baldano. Baldano is. Just one second. I open your name. Level one, level two. Yes. Submit it. Baldano. Uh, midterm. Lab four. Yeah, lab two. There's a lab four you submitted. Yes.
Do you see it?
Yes, not lab three.
Oh,
Lab three we did in the class lab three. Let's say today we did the lab five also in the class. Okay, that you'll see in the some slide. You have the lab one, lab two. That slide you have to practice. Okay, that is the thing.
okay.
Since the answer is given there, I'll not discuss too much about that. But the some lab is unknown. That lab I'll try to give so that you can think and you can submit. But you have to focus more on your final exam and next quizzes or assignment. Okay,
Okay.
well, then take care.
All right. All right, you have a good day,
Anything more?
Professor.
Okay, take care. Anything more? Okay, great.
Can you hear me,
Yeah, yeah.
Professor?
Clay boy, I give you attendance. Enjoy your day. Okay, great. Okay, no problem. You too. Okay, I'm going to open it for today's. You have to submit. Okay, by today's. Okay, no problem. Great.